Hi, and welcome to day 8 of Trig Graphs. This is our last day of Trig Graphs. I already scanned these into the computer, these notes, already handwritten. I know you guys don't necessarily like when I do that, but there was so much writing, I was never going to be able to fit it all on where you could actually read it, because it's hard to write on here at times. So bear with me. If you need to, obviously, just stop the video and copy down what you need to copy down, and we go from there. Today we are going to be doing the reciprocal functions, okay? And the first one we're going to start out with is cosecant function. And cosecant is equal to 1 over sine. So that means we use the reciprocals of all the sine function values to graph our cosecant. And some things that you kind of need to remember: the reciprocal of 1 is 1, and the reciprocal of -1 is -1. So those values don't change. So that means that the sine function and the cosecant function are going to touch when sine is 1 and when sine is -1. The reciprocal of a positive number less than 1 is a number greater than 1. So, for example, if I have a positive number less than 1, 1/2. The reciprocal of 1/2 is 2. So that's a number greater than 1. So if I have a fraction and I find the reciprocal, I'm going to end up with a whole number. And the reciprocal of a negative number greater than -1 is a number less than -1. So if I have a negative 1/2, because negative 1/2 would be greater than -1, because negative 1/2 is closer to 0 than -1 is, and I take the reciprocal of that, I get -2. So that's a number larger than -2. So it's going to be, sorry, it's going to be less than -2, which means it's going to be smaller, farther away from 0. The reciprocal of 0 is undefined, because we'd have 0 over 1, and that's 0. And if you take the reciprocal, you have 1 over 0, and anything over 0 is undefined. So therefore, the reciprocal values of the sine function exist between -1 and 0, but not including 0, and then again between 0 and 1, but including 1 and not 0, because at 0 you're going to have asymptotes. The range of the cosecant x is going to go from -infinity to -1, and 1 to positive infinity. And so for the integral values of n, the vertical lines at x equals n times pi are asymptotes. So that means that pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi, all of those values would be asymptotes because it's multiples of pi. Okay? Okay, so the easiest way to actually graph the secant or cosecant function is to actually graph your sine function, which we have right in here. This is my sine function. And everywhere I have a minimum or maximum is where my cosecant is actually going to touch my sine curve. So here they share a point, here they share a point, and here they share a point. Every time my sine function crosses the x-axis, I have an asymptote. So I have one here, here, and there would be another one over here, and there'd be another one over here. And then basically what you're going to do is draw little parabolas in between. Now, if you're given the cosecant function and you're trying to figure out which function it is, draw the curve in between the graph, and that will tell you what it is. It's reciprocal. All right, let's look at secant. The secant of x is equal to 1 over cosine x. And so we will use the reciprocals of the cosine function values to do these. The reciprocal values of the cosine function exist between -1 and 0, but not including 0, and 0, not including it, all the way up to 1, where you are including it. The range of the secant goes from negative infinity to -1, and again from 1 to positive infinity. None of this changes because sine and cosine are essentially the same curve. This cosine has a phase shift of 90 degrees. So all that information about the reciprocals and the positives and what's less than 0, what's greater than 0 from above all still hold true for this. What's going to happen, though, is for the integral values of n on the vertical lines, x equals pi over 2 plus n pi are your asymptotes. This is just another way of saying your odd multiples of pi over 2. So that's what that's really saying, is the odd multiples of pi over 2. We talked about those yesterday, or not yesterday, the other day in class, when we were talking about the tangent curve and where my asymptotes were with my tangent curves. They were at pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, anywhere that cosine was equal to 0, we had an asymptote. Well, that's going to hold true for secant, because anytime cosine is equal to 0, I'm going to have an asymptote. So when they're 1, the graphs touch, and zeros are my asymptotes, which is already drawn in. And then if I just connect my points in between, I can see that this equation is indeed the reciprocal of cosine, because I can fit the cosine graph in between there. All right, cotangent. Cotangent's 1 over tangent, x. We use reciprocals of the tangent functions for our values of x that are multiples of pi, and tan x is equal to 0, and that would be when cotangent is undefined. For values of x for which tangent is undefined is when cotangent is equal to 0. For integral values of n, the vertical lines on the graph at x equals n pi are the asymptotes. So anytime cosine would be equal to 0 is when you would have your asymptotes for the cotangent function, because it's sine over cosine. If you notice, the cotangent curve is always decreasing, and our tangent curve is always increasing. The tangent curve is the one that is dotted on the graph, and the cotangent is the one that's just done in black. So they are, okay, reciprocal functions again. So tangent is always increasing, cotangent is always decreasing. So let's look at our little chart here. None of these graphs we have to worry about the amplitude. It's not like when we're doing just a sine or a cosine curve. We have to worry about the amplitude. Don't have to worry about an amplitude here. Our maximum values for cosecant and secant are both positive infinity, and same thing for cotangents, positive infinity. Our minimum is negative infinity for everything. Period is how long it takes to complete one cycle. So the period for cosecant and secant is 2 pi, because that's what the period is for sine and cosine, and it's just a reciprocal function. And cotangent, the period is pi, because that's what it is for a tangent. That's how long it takes to complete one curve. The domain for cosecant is x cannot be it'd be x such that x is not equal to n times pi. So multiples of pi. And for secant would be x cannot be equal to pi over 2 plus n pi, meaning the odd multiples of pi over 2. And the cotangent has the same domain as the cosecant. And the range for the cosine, or sorry, the cosecant and the secant is actually the same, just like with sine and cosine. And for cotangent, it goes from negative infinity to positive infinity. All right, that is it for today. And that's actually it for the unit.